Hello, students. Today we will tackle a very important topic, the physical properties of carboxylic acids. Now, this is a topic where many questions are asked, especially reasoning-based questions, so understanding the concepts clearly is very important for your exams. Let's begin.
So let's start with a very curious question. Have you ever wondered why carboxylic acids have such surprisingly high boiling points? Especially when you compare them with other molecules like aldehydes or ketones that have almost the same mass. What makes them so different? Let's investigate this puzzle.
Just look at this data here. We have propanaldehyde and acetone. Their molar mass is 58 grams per mole. And then we have acetic acid with a molar mass of 60 grams per mole. Almost the same, no? But look at the boiling points. For the aldehyde and ketone, it's 49 degrees Celsius and 56 degrees Celsius. But for acetic acid, it is 118 degrees Celsius, a huge jump. So what is the reason for this? Why is this happening?
Well, the entire secret lies in the functional group itself, the carboxyl group, the COOH group. This group has a very special ability, a unique capability that other groups simply do not have.
Okay, now what is this special ability? It is a dual nature. See, the COH group can do two things at the same time. The hydroxyl part, the minus OH, it can act as a hydrogen bond donor. And the carbonyl part, the C double bond O, can act as a hydrogen bond acceptor. This ability to both give and take is the main point here.
Please remember this point. This dual capability is the reason for everything that follows. Think about it. Aldehydes and ketones, they have this C equals O group, so they can accept a hydrogen bond. But can they donate one? No, they don't have a hydrogen atom attached to a highly electronegative oxygen atom like carboxylic acids do. This is the key difference.
So how does this dual ability play out in a collection of molecules? What happens when you have many carboxylic acid molecules together? Let's see how this creates what we can call a strong molecular community. Yes, a very good way to remember this is to think of these molecules as being very social. Because each molecule can both give and receive hydrogen bonds, they are able to form very strong connections with their neighbors, building a very tight-knit community. In fact, they're so social that they often form pairs. In nonpolar solvents, or even in the vapor phase, two carboxylic acid molecules will pair up. One molecule's OH group forms a hydrogen bond with the other C equals O group, and the second molecule does the same thing back to the first one. This stable unit of two molecules held together is called a dimer. And this is not just limited to pairs. In the pure liquid state, this behavior extends to create a large, three-dimensional network. You can picture it like a spider web, where every molecule is connected to many other molecules through this extensive hydrogen bonding. Now, just think for a second. If all the molecules are held together so tightly in this community, like in a net, what does that mean for their physical properties? What will be the consequence? Exactly. It means we need to supply much more energy to pull these molecules apart from each other and turn them into a gas. To break this strong network of hydrogen bonds, a lot of heat is required. This is why their boiling points are significantly higher. This also explains their high solubility in water, because they can easily form these strong hydrogen bonds with water molecules also. Okay, so let's quickly do a recap of the main idea. What is the most important thing to remember for your exam? So the most crucial concept is this. The COOH group is both a hydrogen bond donor and an acceptor. This special ability allows carboxylic acids to form very strong intermolecular hydrogen bonds. Because of this, they form stable pairs called dimers, and even larger networks in the liquid state. And this extensive bonding is what results in their very high boiling points. So just remember this one idea of social molecules that form a tight community. If you can remember this picture, you will never forget this concept. This topic will feel much lighter in the exam. Keep studying and you will do very well. All the best.